Hello students, welcome to Economicspedia. So welcome to the third part of game theory, and in this session we are going to solve games without saddle point. Now, whenever we have a payoff matrix with us, it is not possible and it is not always compulsory to have a saddle point solution. Now any one of you is wondering about how to solve game with saddle point, you can click on the link or the card you can see right over on this side of the screen, or you can also find the link of the previous two parts as well below in the description box. Please take a look at that. Now, so when in a payoff matrix, if the max-min value is not equal to the min-max value of the payoff matrix, then we cannot say that there exists a saddle point. Okay, so this is the main criteria when the saddle point will not occur. So the condition for no saddle point is max-min value is not equal to min-max value of the game. This is the main condition. Then how to solve it? So whenever this is the condition that min-max value is not equal to max-min value, so this is nothing but it simply says that there exists no saddle point. And as no saddle point is there, so we can say that the pure strategies in order to develop the saddle point is completely useless. So the pure strategy game does not work here, or pure strategy concept. So what's the concept that is applicable into this scenario? It is the chance move concept that comes into the picture. Chance move. What does this mean? Now, when a choice from a set of strategies is made not from decision but from the random chance of choosing or going for a particular strategy, that is a condition for this chance move. As an example, you can consider the toss of a coin or throwing of a dice. Okay, so these are the examples of chance move. Under this criteria, the games without any saddle point are being solved. Now, as I have mentioned that the pure strategy principle in order to solve the game is not workable, at least in this case. So here the term the mixed strategies comes into the play. Mixed strategies. Now, what used to happen under the pure strategy principle? Each and every player used to choose a particular strategy, then the second or the next player comes into the play and that player chooses his or her strategy. Right? In that way the pure strategy principle works. How the mixed strategy works? Well, in mixed strategy, if we have suppose two players, as I have mentioned in the first part only, we are going to discuss the whole game theory with respect to two players. So that gives you a clear concept on that. And majority of the questions have always come from these two-player games. So what happens in mixed strategy is that the player 1 or player A, suppose, continues to play his each rows. So player A continues to play each rows for a certain period of time. And after player A is done, player B comes into the picture and then player B plays his each column for a period of time. Okay? So player A is playing each of his rows for a certain amount of time, and player B plays each and every column of his for a certain amount of time. Now the question that arises that for how long each and every player will continue to play their own strategies. For that, we are going to attach some of the probabilities in order to attain the ultimate value of the game. Okay? So let's move toward the next section of the discussion, where I am going to discuss the whole theory that I have just discussed right now with the help of some variables. And in the third part of this session, we are going to discuss the game without any saddle point with the help of a numerical example. Okay, so stay tuned until the last part. Let's move to the second part of the discussion now. Okay, in the second part, let me take up a payoff. As I have said, arbitrary payoff. So I'm writing player B, and or let's do one thing. Let me keep the payoff matrix on this side because we will be needing this, and let's say player A on this side. Now the strategies for player A is A1 and A2, and for player B is B1 and B2. The payoffs are A11, A12, A21 and A22. Okay, so this is the payoff matrix we are concerned about. Alright, now as I have said that the two players are going to play the mixed strategies. Okay, let's say suppose player A plays mixed strategy. We can denote it as by the matrix SA like this. What is this A1 and A2? A1 and A2 are the strategies available to player A. And what is this P1 and P2? P1 and P2 are the probabilities that I have just mentioned, that in order to solve for the ultimate value of the game, we need to include some probabilities. These are the probabilities, P1 and P2. And one more thing, that here P1 plus P2 is equal to 1. Okay? And one more thing, the summation of the two probabilities is equal to 1. Now, so this is the mixed strategy of player A. Now let's say player B plays his strategy B1. If player B plays B1, then the net expected gain of player A, what it will be? Let me write it as E1P, that is equal to A11 into P1 plus A21 into P2. Okay. In the same way, if player B plays his strategy B2, then the expected gain by player A is given by E2P. So here similarly we can write this. This is A12 into P1 plus of A22 into P2. Right? So these are the net expected gain by player A when player B plays strategy B1 and strategy P2. Try to note it down, and let me move to the second part of the game when we will be considering the mixed strategies for player B. Okay? Now, so the mixed strategies for player B, let me give it again in a matrix form like this. Now here the probabilities are Q1 and Q2. So again the summation of Q1 plus Q2 is equal to 1. Right? So this is it. Now let's say, just as in the previous case was, player A suppose plays strategy A1. If this happens, then the net expected loss of player B because player A was having a gain. So that is why here player B is having a loss. Ultimately these are all zero sum game, right? So expected loss, it will be given by E1Q is equal to A11Q1 plus of A12 Q2. And similarly, if player A plays his strategy A2, then the expected loss of player B will be given by E2Q is equal to A21 Q1 A22 Q2. Okay? So these are the expected net loss of player B, and the previous ones were the net expected gain of player A. Now, if we assume that V, let's say capital V, okay, this one, I am saying this as the value of game. Then how to find this value of game? To find the value of game, we have to take into consideration an equality of this one and this one. These two equations we need to solve in order to find the value of this V. Okay. Now, one more thing, if you solve this, let's say this is equation 1 and let's say this is equation number 2. So, from solving equation number 1, you can find the value of P1 as A22 minus A21 divided by A11 plus A22 minus A12 plus of A21. This is the value of P1, and from this identity, from this condition of P1 and P2, you can find the value of P2. From equation 2, so this you can get from 1, and similarly, let me write it over here. From 2, the value of Q1 is A22 minus of A12. The denominator remains unchanged, that is A11 plus A22 minus of A12 plus of A21. And once you have this Q1, you can easily find the value of Q2 as well from this equation. Okay, so you have the values of P1, P2, Q1 and Q2. So once you have the values of all these probabilities with you, then it is very much easy to find the value of V. For V, we need to equate V with any of the 4 expected values that we have got. The expected values, if you can recall, that it was E1, it was E1P, you can equate this with V, E2P, or from E1Q, E2Q. And with any of the equations, if you equate V, you will get the value of V, and that is the solution of the value of K. So this is the algebraic explanation towards the solution without any saddle point. Now let's move towards the numerical example of how to solve game without any saddle point. So as you can see, our numerical example written on the board. So this is a game of tossing a coin. Alright, and here are the head and tail. H and T represents head and tail. This is player B, this is player A, and this is the payoff matrix. Now as you can see, if you try to solve it with the min-max, maximum-minimum strategy, then you cannot find any saddle point. So that is why I have taken up this example in order to solve you for how to solve the game if there is no saddle point. So all you need to do is, the number one thing to remember is you have to attach the probabilities P1, P2, Q1 and Q2. So from the previous discussion of in a general algebraic form, let's write it down, the value of a11. What is a11 here? It is 1. Write it. What is a12? It is -1. Similarly, a21 is -1 and a22 is 1 again. Okay, so starting with the probabilities, let's find the value of P1 first. What's the value of P1? How to get it? You see in your in this a bit earlier only we have find the value of P1 and P2 by solving the equations of the net expected loss and the net expected gain. Right? So from there, once we substitute the variable with this numerical value, we can have the value of P1, that is probability. So in algebraic version, what was the value of P1? It was equal to A22 minus A21 divided by A11 plus A22 minus A12 plus of A21. This is the value. Now, if we solve it, what is the value of A22? It is 1 minus. What is A21? A21 is -1 divided by A11 is 1 plus A22 is 1 minus. What is A12? -1. And what is A21? That is again -1. So if you solve it, you get the value of P1 is equal to half. So that implies the value of P2 is also equal to half. So this is also equal to P2. Okay. Now let me find the value of Q1. Why? Because we need the values of all the probabilities in order to find the value of the game. That is the ultimate motive. So Q1 is A22 minus of A12 divided by A11 A22 minus of A12 and A21. Again, all we have to do is to substitute the numerical value into this. So A22 is 1. What is A12? That is again -1 minus of -1. And the denominator remains the same. So all I'm doing is copying it from above. And if you solve this value as well, you are going to get the value of not only Q1 but Q2 is equal to half. Okay? Now, so we have the values of P1, P2, Q1, Q2 all is equal to half. P1 equal to P2 equal to Q1 equal to Q2. Everything is equal to half. Now we need to find the value of gain. That is the value of V. So, as I have mentioned in the previous section only, that we can equate the value of gain, that is V, with any of the net expected values. So I am equating E1 P with V. So after solving it and after substituting the values of P1 and P2 into the equation of E1P in the algebraic form, then you will obtain the value of gain as A11 into A22 minus of A12 into A21. This divided by A11 plus A22 minus of A12 minus A21. So this is the value of gain that you are going to obtain once you have substituted the value of P1 and P2 in the equation of E1P with this algebraic values. You are going to obtain this one. So here in this numerical example, all we have to do in order to find the value of gain is to substitute the numerical value into these variable values, into these variables that are here. Okay, so let's do that. So what is A11? A11 is 1. A22 is 1 again. So 1 into 1 minus what is A12? It is minus 1, and A21 is again minus 1, and we have this as plus. What is A12? A12 is minus 1 and minus 1. Now, if you solve this value or this equation, you can find the value of game coming to be 0. Don't worry, the value of the game can be 0. Okay? If any of the question, if any one of you is thinking that how the value of game can be 0, it is possible. Alright? So this is how we are going to solve for any of the game if we don't have any saddle point. Okay? I hope this session was helpful to you, and if it was, don't forget to hit the like button and subscribe to our channel if you are new. You can also find many other lecture series on economics as well as different competitive exams in the following playlist. You can simply go and check it out. Thank you for watching this.